Fitting an aftermarket pedal box is a relatively common modification for building a race car, and there's a lot that goes into what you need to consider, particularly around master cylinder sizing. To talk around this, we've got Daryl here from Perusic Engineering. And Daryl, you make your own pedal boxes and you've got quite a lot of information around what you need to understand about sizing the master cylinders. I think it's something that a lot of people really overlook, thinking that they can get around incorrectly sized master cylinders simply by adjusting the brake bias, because after all, that's one of the reasons why we fit a pedal box, so you can adjust the bias front to rear. It's not quite that simple though, is it?
No, there's a lot more to it. There's a lot of cases where if you pick, let's say, two different master cylinder sizes and put one on the front, one on the rear, the bias bar itself will only have a range of adjustment anyway. So you're either going to be in the window or not. Okay.
However, we really want to be as close to central on that bias bar as we can.
Definitely. The more you are off to one side, it can have other influencing factors that aren't desirable. But predominantly, the main thing is once you get the car's dynamic behaviour estimated from knowing its centre of gravity and wheelbase, you start to then dig a little bit deeper. It's all totally relative to the caliper. And if you mismatch things, you'll get a lot of stroke on one side of the balance bar compared to the other. And that tends to lead to bias migration, which is another downside.
Okay, bias migration.
Yeah.
Expand on that a little bit. What are we talking about when you use that term?
So let's say we just had a simple case of you wanted 60% front brake bias. As you press on the pedal initially, you might go for the hard application. You have to modulate off as your speed drops off, as weight transfer drops off. And what happens in that case, the balance bar potentially pitches, and the angles that it makes affects the amount of force that goes down the push rod. So you might start off at 60% and end up at 55 or 50, or it might go the other way around.
So you've got an inconsistent bias depending on if you're braking really, really hard versus a light brake application.
Most definitely. And that variation can easily be 5 to 10% on a bad setup.
Okay, so hopefully we've clarified that we can't just go and stick any size master cylinder on a pedal box and then think that we're going to fix it with the bias. There's a bit more that we need to consider. So what is the process? What do people need to go through in order to decide on what the correct master cylinder size is? Is it something we can nail down in theory and be right on the money, or is there also an element of testing and validating?
You can definitely do it through testing and validating. We've spent a lot of years in developing our own software packages that not only look at the brake issues, but also dynamic grip issues, how responsive something is. Now, not to stray away from that, you're really better off starting at the tyre, back through the suspension and where the COG is on that car. That then really identifies how much braking energy is potentially going to be needed at the front and rear for the biggest braking application, like the biggest Gs.
So centre of gravity, wheelbase, you've said the tyre is an element there. I can only imagine that we also need to factor in the size of the brake package front and rear as well.
Yeah, for sure. So once you start working from the ground back, you'll come to the rotor, then you'll come to the caliper. So there'll be a ratio of how much braking effort would go into through the front brake package and the rear brake package. You fundamentally want to have those at the right proportion to suit what overall brake bias you want. And imagine a car might have the same brakes front and rear. Kind of ridiculous because the back isn't going to do much.
And that's another combination we do see quite often, people basically over-braking the rear of the car needlessly, correct?
Oh, definitely.
Now, that term you used, just to come back to the numbers or the data you'll need for these calculations, centre of gravity height. Now, wheelbase is pretty easy for most people to measure with a relatively high degree of accuracy. Centre of gravity height, that sounds like a hell of a lot more work and a lot more complexity. Can you give us maybe a quick overview of how that is measured and validated?
Yeah, so look, I mean, the simple thing everyone does is put their car on scales. You can work out how much is front and rear. And that really gives you a vertical line through the middle of the car where, let's say a vertical plane through from between the front and rear axle, as in the centre of gravity is somewhere along that. All you're trying to do is work out the height. So that can be done by pitching the car. People have got their own weird methods of doing it, which can all work. But ultimately, you need another method which gives you another line at a different angle, which means if you pitch the car up on scales, recorrect your wheelbase when it's pitched, get the reading, you could almost do a bit of math or even draw it out and solve by geometry.
I mean, the technique I've seen used, and we've used it in our own suspension course as well, is lifting the front of the car up on a hoist while the back's still on scales. And as you say, a bit of math, you can sort of get a reasonably accurate idea of where that centre of gravity height is. Yeah. Now, can I assume that this design process is something that you do for your customers?
We do.
And is there other options if people are maybe trying to do it at home? Is there online calculators that kind of will get people in the ballpark, or is this information sort of pretty proprietary?
So the stuff we've developed, we use, because there's so many variables that I think if you just put an automated calculator up, it's potentially going to be misunderstood or misused, and they may not get the correct outcome they were after. So I think having that deeper understanding of trying to balance everything up all the time, you can't just look at one thing as a balancing factor. So if you had a fixed brake package, you changed tyres, for example, and you said, I'm just going to use that same balance bar setting, it's not going to work. So you've really got to re-look at what else is making up your system. And keeping all things in balance, you would be running equal line pressure at front and rear circuits, which means the same, let's say, not necessarily the same force on the pads, but depending on the pistons, front and rear, the same proportion of master cylinder to brake caliper as a piston area combination, front and rear. And if you can match that and still be in the right window, that's probably the best place to start.
Now, another element that I'm interested to talk a little bit about is the integration of ABS with a pedal box. The likes of the Bosch Motorsport ABS system, which is pretty popular obviously on high-end race cars. It's not a cheap unit, and obviously it can be incredibly effective. Does that sort of eliminate the bias issues that we've just been talking about? Is it a case of just letting the ABS fix any errors in our master cylinder sizing, or does that master cylinder sizing still play a part with an ABS system?
Yes, so I think a lot of people would consider that as soon as they put the ABS on, all their problems are going to go away. You're really wanting the ABS to work for you in the sense of limiting the amount of braking effort you're putting when you apply too much. If you didn't have your proportion correct as a front and rear combination to start with, and it started to limit the front or the rear as a result, you might not potentially be getting as much as you need at the other axle.
And the upshot of that, of course, is you're not getting maximum braking performance at that axle line?
Correct. So really the only way to overcome that would be to put in extra pedal effort.
So essentially the driver has to work harder on the brakes, and obviously you've got one axle line. The ABS interaction, or intervention I should say, is more intense because you still haven't built up to maximum braking force at that other axle line. So the ABS is then maybe not able to do its job as well either?
Oh, correct. I mean, the best driver would actually be right on that limit without requiring the assistance of the ABS. So if the ABS is a momentary lock up and then let go, and a lock up and let go, you've lost your maximum braking ability. So if you could manage to have the ideal bias set to start with and feel with the pedal, then you're only relying on the ABS if you make a mistake.
All right, it's great to get some insight into that, because it is a topic that I think a lot of people just would not give any thought to. And again, as I've mentioned, think that everything can be fixed with the bias. Obviously, as we've learned, that's not the case. If people want to find out more about your pedal boxes, where can they do so?
Oh, look, our website's got all the information. That's where people, if they wanted to have the brake analysis set up, done for their car, they can download the form, fill it in. So there should be enough there to get people going.
Perfect. Thanks for your time, Daryl.
Welcome.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.